Welcome to the unit on quality assurance. This unit introduces apparel quality assurance and comprises of 3 modules and a final review section that invites you to reflect on what you have learned. By the end of this unit, students will be able to describe the different methods of maintaining quality in the apparel manufacturing industry, outline the standards and guidelines used in the apparel industry. The first module explains the importance of making quality measurable. The word quality has multiple meanings. 2 of those meanings are critical not only to quality planning but to strategic business planning as well. They are product performance and freedom from deficiencies. In the sense of performance, quality refers to the performance feature of a product. Such features are decisive regarding product performance and product satisfaction. They compete with each other in marketplace. External customers, especially ultimate users, compare competing performances. Their comparison then become a factor in deciding whose product will be bought. Due to competition in the marketplace, a primary goal for product performance is to equal or superior to the quality of competing products. There is much demand for apparel with a very high quality in the marketplace. The word quality also refers to freedom from deficiencies, which takes many forms such as late deliveries, customer claim and returns, high rate of rework, even cancellation of sales. These are collectively forms of product dissatisfaction. Some deficiencies impact external customers and hence are a threat to future sales as well as a source of higher cost. Other deficiencies impact also customers and hence are mainly a source of higher cost. For quality in the sense of freedom from deficiencies, the long range goal is perfection. With this in mind, quality can be defined in different ways. It is constructing solution to problems before they occur and designing excellence into a product or service. The delight of the ultimate judge of how well products and services measure up. Quality is productivity from employees who receive training, tools, instruction that are needed to execute their jobs. It is willingness to change in order to meet demands. It is doing things quickly and correctly. It is a schedule being on time. It is the process of ongoing improvement. It helps in reap a payoff because in the long run, doing it right the first time is less expensive than correcting it later. Many companies require regular reports but take no action to bring about improvements as a result of those reports. A heavy focus is placed on measuring systems and methods instead of result and possible improvements. Measuring a process without improving it leads to increased cost and lower product quality. If all new product development costs are due to failures because measurements are not monitored and effective solution not planned. What gets measured gets managed. Conduct of the quality function depends heavily on the quantification of the product and process characteristics. The process of quantification is called measurement. The measurement results are dependent on standards being used. Improvement occurs when the measured results are monitored and compared against standards, resulting in actions. The measurement of current performance is essential for continuous quality improvement. What cannot be measured cannot be improved. There is no end to quality improvement processes when results are continuously monitored. Companies measure sell profit growth and other parameters to satisfy stakeholders. It is better to monitor the process that provides these results rather than measure the results alone. Results will follow when input is controlled and the process is monitored. A very effective control system is required to ensure that the whole product stream meets specification with only a tolerable amount of exception. Most companies follow the three-tier system of quality checking. The best results have been found to be achieved with the system, which are three components activities linked by a manager report. They are in-process sampling, 100% examination and quality audit. These modules explain the importance of quality assurance in the garment industry. Quality assurance refers to the assurance to customers that our product, parts, components, tools contain specific characteristics and is fit for the intended use. In today's competitive industrial world, no business unit can exist for a long time without adhering to quality. Now, the assurance of quality is not the responsibility of a senior person or a department only. Only the inspection department or its personnel cannot be held responsible for assurance of quality. It is responsibility of everyone connected with production, directly or indirectly, and each department. Main objective of quality control are to identify and mark fabric faults on the fabric, to decide whether to cut the fabric lot or not, to increase productivity of the cutting department. Quality products require quality piece goods. Even the most outstanding manufacturing methods cannot compensate for defective materials. You can use these recommendations to help create an aggressive piece goods quality control program and eliminate many quality problems before the manufacturing process begins. Here are some inspection guidelines. The fabric store should always inspect the fabric as soon as it reaches the facility. Always store the fabric in a clean, moisture-free environment. As soon as fabric arrives, a swatch or of dimension as specified by the laboratory should be submitted to a laboratory to check the fabric for adherence of fabric performance standards that are required. Many companies prefer to undertake fabric checking while spreading. This is because while spreading, a spreader is concerned primarily with spreading the fabric, not to inspect the quality of the fabric. Let us now review important inspection standards to be followed. These are 4-point system: inspection of fabric metrage, roll size, selection of rolls, classification of defects, acceptance point count. The 4-point system is widely accepted in the textile and garment trade because it is easier to understand and implement. This system also lays down standards that are proven and acceptable in the garment trade. It is recommended to use same system while checking fabric. In the fabric metrage to inspect system, at least 10% the metrage is to be inspected. For a shipment or order of up to 200 meters, it is recommended that inspection should be carried out for 100% piece goods. For a shipment between 200 to 2000 meters, inspection should be done for at least 200 meters on 10%, whichever is greater. Roll size. For better utilization of fabric, it is suggested that there should not be more than 10 to 15% short rolls, that is the rolls of 20 meters or less in the order. Selection of rolls, at least one roll of each color, that is even if it exceeds 10% the total meterage should be selected. In case more than one roll per color to be checked, Then select the number in proportion to the number of total rolls per color received. The 4-point system classifies defects as shown in the table. For 3 inches or less, 1 penalty point. For over 3 inch but not if over 6 inches, 2 penalty points. For over 6 inch but not over 9 inches, 3 penalty points, and over 9 inches, 4 penalty points. For holes and openings, for 1 inch or less, 2 penalty points. For over 1 inch, 4 penalty points. A maximum of 4 points is charged to 1 linear meter. Defects less than 1 inch from the selvage of the fabric will not be counted. Only major defects are considered. A major defect is a defect that, if conspicuous on finished product, would cause the item to be a second. A minor defect is a defect that would not cause the product to be termed as second either because of severity or location. Major defects are classified as major woven fabric defects, major knitted fabric defects, major dye or printing defects. Accepted point count. This method of acceptance used as a projection of total defects based on the number of defects found in an inspection of a sample. This method of acceptance uses a projection of total defects based on the number of defects found in an inspection of a sample. For example, the points are calculated on a 100 square meter basis. To calculate the average points, 100 square meters for the shipment. Total points counted for all roll inspected into 39 into 100 divided by total meters inspected into cuttable width in inches. Up to 40 points per 100 square meter is the acceptable defect rate. The objective of quality control in spreading and cutting are to ensure that all garment parts are cut as per the pattern. Decide if garment parts have to be recut. Increase productivity of the sewing room. The word quality have multiple meanings. 2 of those meanings are critical. It's not only to the quality planning but to strategic business planning as well. These are namely product performance and freedom from deficiencies. For quality in sense of freedom from deficiency, the long range goal is perfection. Quality can be defined as quality is prevention, as also it has been told like that prevention is always better than the cure. So prevention is the one of the major tool if you talk about the quality. The prevention, quality is prevention, basically the constructive solution to problems before they occur and designing excellence into a product or services. Quality is customer satisfaction. The another definition says this is about the delight of ultimate judge of how well products and services measure up, because we talk about the customer as a god and customer is the king in fact. So customer satisfaction is utmost important if any product satisfaction is we talk about. Then quality is definitely the productivity. From employees point of view, if we see that who receive the training, the tools and instruction, they need to execute their job. The productivity, the quality and productivity goes hand by hand. If the quality is not, inferior quality is there or quality is not up to the mark, definitely productivity will go down. Production of that particular product will go down, because again and again if the company is facing the quality problem, then definitely the productivity cannot be more. That's why it's told like the quality and production both are, we can say that, go hand by hand. Quality is also flexibility. Now, next definition is quality is flexibility. The willingness to change to meet demand is also called is as a part of the flexibility, because in the quality should be very flexible. The moment buyer changes their demand about the quality parameters, about the even the product changes, the quality requirements used to change. So it should be flexible. Quality should be very flexible to adopt the changes whatever is required from the buyer, or whatever has demand already given by buyer. Quality is efficiency, doing things quickly and correctly. That also as a quality. Like the efficiency, as we discussed about the quality, is productivity, and efficiency is basically the to speed up the production, to speed up the whole manufacturing process. Quality has to be has to be correct. Then we have next one is quality is a process. It's basically is a ongoing improvement. It's a process. It's not like that once you set up the quality parameters, then everything will be keep moving on. No, we have to. Once you have set up the quality parameters, once the quality system has been on place, then also the process, in the process it has to be the continuous improvement should be there. The next one is the quality is an investment, reaping a payoff, because in the long run doing it right the first time is less expensive than the correcting it later. As in industry, if you see about the quality, if we are having the problem in the product, then the product will go for rejection, or it will go for repair. The rejection and repairs both cost a lot. If the repair has to be done in the product, then in that case what happens, take example of a garment, one operation of the garment. Suppose in a trouser the side seam operation has been done, and we found some problem in the side seam operation. Side seam operation has been done by using the feet of the arm machine, and feet of the arm machine we found some problem, like in the side seam operation. We found the problem like there is raw edge has come out during that particular operation. Now again what has to be done, suppose the standard time for that particular operation is suppose 0.4 minute, and that 0.4 minute of the time, once you have done the side seam operation, again we found the problem, again it has to go for the ripping. We have to open the complete seam, so one person has to be employed for the opening of the complete seam. So say like 0.4 minute of the time the operation time was, then ripping time will be not less than 0.6 or 0.8 minutes. Now 0.6 or 0.8 minute of the ripping time we are using that. Again we are doing, after doing the correction, we are again doing the stitching. So total time in the place of 0.4 second or 0.4 minute, it is 0.4 plus 0.6 plus 0.4, it is 1.4 minute. So basically in the place of 0.4 minute, the total time after the whatever the correction is required, whatever the repair is required, is taking 1.4 minute. So it means that we are basically losing more than twice of the time whatever it should be. Like in the place of 0.4 minute time, we are using 1.4 minute of the time for that particular operation. And although this is not done in the first go, so there may have the needle holes problem, there have some other problems also. So we are losing the time also, we are not giving the correct product also. Even the repair, after the repair, we cannot assure that whatever the product has been made will be foolproof, because of these earlier whatever the needle holes are there, or already the unnecessary crease marks was there. So maybe it will not give the same look what the first go, without any failure in the quality the product is going with. So that's why it's still that quality is an investment. Quality in investment in terms of time, quality in investment in terms of the efficiency, quality is investment in terms of productivity also. If the quality is on track in any company, then definitely the productivity of the company, productivity of that particular product, productivity of that particular line will be more, the efficiency of the line will be more, and definitely the utilization of the man machine material will be more. So quality is an investment. Then how to make, next question comes, how to make quality measurable? What are the parameters are there? How we are going to measure the quality? Many companies requires regular reports, but they don't take any action to bring about improvements as a result of those reports. For sake of getting the reports is not going to help a company. So many types of the MIS is being used, being made in the company. They are using their ERP software, they are using their Excel, Microsoft Word, they are making a number of reports. But how much you are going to, if your report will show you the figures, the data, where you are, but action has to be taken to make those. People are more bothered about the production rather than the quality. They forget about that. Quality and production will go hand by hand. If the quality is not correct, production cannot go. If quality is bad, then productivity, you cannot accept the more productivity. So that is the problem still in the garment manufacturing, especially in the garment manufacturing industry, these problems still persist. So the heavy focus is placed on the measuring systems, methods instead of result and possible improvements. They are putting the lot of measures, they are putting the lot of focus on measuring systems, methods, instead of they have to think about the results and what are the possible improvements are there which can be done. Measuring a process without improving it leads to increased cost and lower product quality. As the survey says, like the 46% of all new product development costs are due to failure because measurements are not monitored and effective solutions are not placed. That 46%, almost half of the new product development gets failed. Quality is in manufacturing, we talk about the quality. In the sampling also the quality, how many samples, how many rounds of the fit we are sending, how many rounds of the sample we are sending, because of we have not understood the demand of a buyer, what customer is looking for. The first go, we are not understood the complete demand of the customer's requirement of the buyer. And even one cycle of fit or one cycle of PP or one cycle of size set we are missing, it means that we are eventually going delay by 10 days or more than weeks. Because if suppose we have sent a fit, that is first fit we have sent, and buyer has given some comment. So fit, we have made the fit, maybe normal sample time of making of the sample time in sampling, they used to take around 2 to 3 days time. Then the fit used to get courier to the destination. In the export orders, the destinations is US, UK or maybe Japan. So the courier will be sent to those destinations. Another 3 to 4 days time it will take. So 3 days of the sample making, 4 days of the time if the product has gone to the destination, it will reach to the buyer. Then buyer has certain days, like some buyers have 2 days in a week when the fit sessions will happen, when they will sit for the whole team will sit and they will see the how is the fit sent by different manufacturing setups. So suppose we have reached our sample and buyer has 2 days, like Thursday and Tuesday. Tuesday and Thursday, 2 days has been given as a days when buyer will evaluate the sample. If my sample reaches on Friday, so we have to wait Friday, Saturday, Sunday, Monday, then Tuesday. For Tuesday evaluation, buyer will check the sample and the buyer will give the comment. So another time is waiting time So we have the 3 days of sample development time, 3 days to 4 days we have the sample will reach to the buyer destination, and then another 3-4 days we have to wait for the buyer comment. So that is the 9 days time itself gone. After 9 days time we will come to know that my sample is okay or buyer has given some comment on that. If the first go we are not able to understand the buyer language, will not understand what is the requirement buyer is looking for, then in the sample state itself we are got delayed by 9 to 10 days. We have to then incorporate those comments in our second fit, and then after we have to send the second fit. After following again the same process has to be followed. Those has to be even one cycle. That's why I just want to give the example of even one cycle we missed, we got delayed by 9 to 10 days in the sampling itself. In manufacturing, where we are making one sample, in manufacturing, if we miss something, the quality parameters we are not able to achieve what is the demand, what has been asked for, what has been parameters has been given, then it's very difficult for a manufacturer to get the order, next order with the similar type of the product from the maybe in the same buyer, because it's also spoil the reputation. It's a long term reputation is spoiled. Short term, definitely the manufacturer will be in a trouble, because he or she is not going to meet the customer requirement. Then the order will not get passed. It will not get passed from the buyer QC or nominated QC of the buyer. That is a short term. The problem can happen. So long term problem can happen, like the order has gone from the hand. Buyer is not going to give the repeat order. To build a relation itself takes a long time, and to spoil the relation is very it's maybe 2 days time or 1 day time, in a fraction of the minute or fraction of the hour it may happen. So the quality is utmost important. The major thing is that quality is utmost important. How you are going to impart the quality, how you are going to implement the quality in the system itself, how you are going to do this one as a quality is a process. I discussed about the quality is a process, ongoing process. We cannot do the system. We have done the quality. Once we set the quality, we cannot make sure that the same thing will go on for a long period of time. No, we have to continuously evaluate that where is the lacuna, where is the problem. So it's written like the measuring a process without involving it leads to increased cost and lower product quality. So what gets measured gets managed. Whatever is getting measured, it gets managed. Conduct of a quality function depends heavily on the quantification of the product and process characteristics. The process of quantification is called measurement. The measurement results are dependent on standards being used. What standard has been used to measure that particular the parameter, that is also important. Different factory, different company have different standards. Even different buyers have different standards. Different like acceptable quality levels are there. So the standard is also very, very important. Improvement occurs when the measured results are monitored and compared against standards resulting in actions. The measurement of current performance is essential for continual quality improvement. What cannot be measured cannot be improved. If you are not able to measure that particular the quality, whatever the quality or product quality, whatever we are looking for, we cannot improve. The measurement is very, very important. There is no end to quality improvement process when results are continuously monitored. So if there is results, we are continuously monitored, we are looking the chart, we are looking on the graph, we are understanding where the quality problems are there, we are going minutely about the different quality tools we are using, then definitely we will not have any problem. The company will not face the problem. Companies measures sales, profit, growth and other parameters to satisfy stakeholders. It is better to monitor the process that provides these results rather than measure the results alone. Results will follow when input is controlled and process is monitored. Then we will discuss about the how to control the quality. What is the tools are there where we can control the quality. A very effective control system is required to ensure that whole product stream is meeting the satisfaction with only a tolerable amount of exception. So the three-tier systems is being followed by different companies for the quality checking. The best result have been found to achieve with the systems which are 3-component activity, which is linked by a management report. So those 3 system tiers are in process sampling, second one is 100% examination, and third one is a quality audit. The system will explain in greater has been mentioned here further. We'll start after the quality control. We want to discuss about the quality assurance. What is the assurance? To control the quality is basically we are going to check that where is the quality, where the problem happening, what is the problem. So to controlling is a tool where we basically after you fall sick and then you are going to doctor, you are meeting doctor for consultation, you are going for the consultation to the doctor and doctor has advised some medicine. You take this medicine, you will be cured. That is the control where already a person has fell sick and he or she is meeting to doctor, and then after doctor is prescribing some medicine and then after the person is using the medicine and he is getting cured. Now we are talking the quality assurance. Why I am going to get sick? That's the main thing, is that we are going to use some precautions, we are going to take some measures, some actions so that I should not get sick. We are going for so many measures like that we are about the food habit, about the doing the yoga, exercises, these things may going to help a person so that the person may not go for a medicine or meeting the doctor. The quality assurance is also like that. It's about the prevention. We are going to set a system in such a way, we are going to place the system in such a way that there should not have any quality problem. So quality assurance refer to the assurance to customers that the product, parts, components, tool, etc. contains specific characteristics and is fit for the intended use. In today's competitive industrial world, no business unit can exist for a long time without adhering to the quality. Like business has to grow, business has to keep coming. For that, a company, a system, a factory, a manufacturer, every stage, in fact buyer stage also, you have to maintain the quality. If the product quality is not good, up to the mark, customer will move from one place to another place, because nowadays competitions are there. There's no monopoly now. People are there, they have so many options. People will move from one brand to another brand to another brand. So it's the customer driven. It will come to brand will speak to the manufacturers, manufacturer will go to supplier. So this is the chain. If you talk about this, start with the customer, because the awareness of the customer is nowadays, and people are knowing what is possible, what is not possible, what he's looking for. So people are more aware about the quality. Okay. So if he is paying, the people are ready to pay the money against the quality product. So accordingly, the each and every systems, this is the chain which is driven by to the last level also. Okay. As a customer has pulled the rope, and it will go, the effect will go to each and every person who is there in the chain. So we are talking about only the inspection department or its personnel cannot held responsible for the assurance of the quality. It is a responsibility of everybody connected with the production directly or indirectly, and each and every department. It's not only that inspection persons who is a quality person who has been recruited as a quality inspector is responsible for the quality, As we discussed about, the controlling part can be done at that stage, even if the person is doing the 100% inspection. If you are doing the audit, I will come on that particular thing, how to do the audit, what are the sample and all. So that's very difficult for the inspector to do, to control 100%. So it should be in the system. It should be, the assurance should be there. That is should be there in the all 3 M's. Like the machine should be calibrated properly. Machine should be should be as per the, like the SPI of the machine should be set properly. The what is the feeding mechanism has to be properly corrected. So each and everything has to be done on the place. The man should be knowing that who is the operator, he should be, or he or she should be knowing that what operation he is going to do. Before that, mock pieces he or should have made. So these all things has to be done. Then material should be the correct, what thread we are using, what needle we are using, what fabric we are using, that the compatibility should be there. Then these all things will go hand by hand, then only we can go for the right quality at the first time. Otherwise, very difficult to achieve the quality parameters what is required. So we will discuss about the quality in each and every stage now. Like we start with the raw material. Raw material first we start with the fabric. In the fabric, what are the quality parameters are there? What are the quality measures are there? Then we will go for the cutting, then we will go for sewing, we will go for finishing. So each and every stage, what are the quality parameters are there which is required from the customer, from the manufacturer. The quality first products requires quality piece goods. So even the most outstanding manufacturing methods cannot compensate for defective materials. This provides recommendations to help to create an aggressive piece goods quality control program and eliminate many quality problems before manufacturing process begins. So this is the first stage. If the raw material is wrong, how we can, if the foundation of the building is not correct, how we can make the building, how we can create the building. The foundation should be correct. The fabric is or trims are the foundation of our garment. If the foundation is not correct, if the trims has some problem, then definitely it's very difficult to achieve the quality at later on. We can brush up, we can give the finishing touch, we can give the pressing. These all touch can be given, but raw material is utmost important. So many quality problems comes from this stage itself. So we have to make sure that the quality of the raw material should be required by the customer. So we have some inspection guidelines are there which will tell about how fabric quality, we will ensure that the fabric quality is perfect. The fabric store should always inspect fabric as soon as it reaches his facility. Like the moment the fabric is coming inside the factory, we have different systems are there, the inspection systems are there. It should be, the moment fabric is reaching there, we should go for the inspection of the fabric. Always store the fabric in clean and moisture free environment. We should always avoid to keep the fabric on floor. We should try to keep the fabric on pallets or racks, so that the moisture content should not go inside, and it should be very clean. If you are keeping on the floor, so many factories we have seen that they are keeping directly fabric on the floor. That is creating the major problem in they can have the fabric can have the shade variation. Fabric will take the extra moisture. It will the fabric will behave, or the fabric will be changed. So these all things are very, very important once we talk about the raw material. So always we should store the fabric in clean and moisture free environment. As soon as fabric arrives, a swatch, which is dimensional of the swatch, is used to be specified, maybe 10 by 10 inch or whatever the laboratories have specified the swatch, should be submitted to the laboratory to check the fabric for adherence to fabric performance standard required. Whatever the standard has been asked, the fabric standard, maybe for GSM, what is the GSM of the fabric, what is the color fastness of the fabric, okay, what is the count construction of the fabric against the whatever is required. So against the requirement we are checking the actual fabric for different parameters, which is always store the fabric. It's already we discuss about that, those parameters. And then many companies prefer to undertake fabric checking while spreading through. So the fabric checks beforehand a separate operation. This is because while a spreader concerned primarily with the spreading the fabric and not to specify inspect the quality of the fabric. So postponing your piece goods inspection till the fabric is on cutting table could have the following effect. It can have the, if we are postponing the piece good inspection till the fabric in the cutting table, can have a delay, can have the different effects can be there. One of them are delay. This is due to the fact that if fabric inspection is done at cutting stage, then fabric is found to be defective. The time lost between fabric receipt and inspection would be additional delay in the lead time of the order. Some factories are there, they feel like the fabric has already checked with the supplier. Now we will do the spreading, and then after we will in the spreading, if some problem is there, so we will take it. So what problem happens, the spreading, if we are doing the checking, fabric checking at the spreading stage, in that case if some problem happens, so the complete process get delayed. So fabric should be done, the checking should be of the fabric should be done at the fabric store only. This also creates a loss of the time and effort. The decision of accept or reject the fabric would be taken only once the entire fabric has been checked. In other words, spread, in case of fabric is found to be defective and has to be rejected, not only the effort and time of spreading this fabric is wasted, but also the time and effort of rolling the fabric again to the return is wasted. Like, we are not wasting the time here in the spreading of the fabric, but after you spread the fabric, again you have to make it roll, and then you have to take it off, you have to send it back to the supplier. So that time also we are going to waste. That is the loss of time and effort in this case. But all the blockage of the cutting table, the time of the cutting master wasted during the process of spreading and then putting the fabric back into the rolls is considerable amount of the time can be wasted. So we are talking about the most acceptable fabric inspection system, which is known as 4-point system. 4-point system is most of the buyer or major of manufacturers, they are following this particular system, because this is widely accepted in the textile and garment trade, because it is easy to understand and implement. This system also lays down standard that have been proven to be acceptable in the garment trade, and it is recommended to use the same system while checking the fabric. So what this system is all about? So it has given in the all the details has been given. What are the parameters has to be followed, how it has to be followed. The fabric meterage to inspect, at least 10% of the meterage to be inspect. The fabric meterage, whatever the meterage is coming, at least 10% of the meterage has to be inspect. For the suppose we got the fabric of 20,000 meters, so at least 10% of 20,000 meters is 2,000 meters. 2,000 meters of the fabric at least has to be inspected. For a shipment or order up to 200 meters, if the order quantity is only 200 meters, it is recommended that for a shipment of up to 200 meters, inspection should be carried out for 100% piece goods. So inspection we should do for all 100% pieces. A shipment between 200 to 2000 meters, inspection should be done for at least 200 meters or 10%, which is where is greater. If the shipment is between the 200 to 2000 meters, at least we should go with the 200 meters of the fabric or 10%, whichever is greater. Let's come on the roll size. It is advised for better utilization of the fabric that there should not be more than 10 to 15% of short rolls of 20 meters or less, that is short rolls in order. So if we are having the short rolls, then we will face the difficulty. So we should always say the supplier that we should not get the short rolls less than 20 meters of the roll. Then selection of the rolls, at least one roll of each color. The next stage is the how to select the rolls. So it is at least one roll of each color, even it exceed 10% of the total meterage should be selected. So we have the 5 colors are there. So from all the 5 colors, we should take the rolls, at least one roll we should select from the each color, so that color apart from the 10%, whatever we talk about the 10% fabric we should inspect, along with that we should also inspect the color wise, because maybe the fabric is correct in 2 colors, but another color there is dyeing problem. So we should not leave that color. So we should check each and every color, even it exceeding more than 10% of total meterage, we should select it. In case more than one roll per color is to be checked, then select the roll in proportion to the number of total rolls per color received. Then we are talking about defect classification. What are the defect classification as there, which is mentioned in the 4-point system about that. Length of the defect, either it's in the length or width. The plenty point has been given, allocated for each and every type of defect. If the defect is 3 inches or less, 1 point has been allocated. So defect, whether it's width wise or length wise, if it is a defect is less than 3 or equal to 3 inches, then 1 point will be allocated for that. So we will talk about the point system here, because we are talking the 4-point system. So over 3 but not over 6 inches, 2 points will be allocated. Between 3, over 3 and less than not over 6, we are allocating the 2 points. Over 6 but not over 9 inches, allocation of the points are 3. Then over 9 inches, allocation of the points are 4. And if there is hole and openings 1 inch or less, 2 points are allocated, and over 1 inch, 4 points are allocated. A maximum of 4 points is charged to 1 linear meter. If the 1 meter of the fabric, we should not charge more than 4 points. If the 1 meter of the fabric, lot of problems are there, still we should consider that particular 1 linear meter of the fabric as 4 point. Not more than 4 points. Defects less than 1 inch from the selvage of the fabric will not be counted. So if there's some constraints are there, what we are discussing right now. If there is defect from the selvage which is less than 1 inches, it should not be counted. Only major defects should be considered. We should not consider the minor defect. And major defect, what is major defect, what is minor defect, that is, I just want to explain that. The major defects are the defect if conspicuous on the finished products would cause the item to be second. If the defect in the fabric which will comes under the major defect, which creates that fabric or the garment in seconds, that comes under the major defect. The minor defects that would not cause the product to be termed as second, either because of the severity of the location. The location may be different, or location may be may not be that severe. So these defects comes under the minor defect. So we should also keep note on that when inspecting piece goods prior to the cutting, it is necessary to rate questionable defects as major, since inspector will not know whether the defect may occur on the item. So we should always have the note on that particular thing, that what we are going to check in the prior to the cutting. We should always rate the questionable defects as major. What are the defects are major? Maybe the inspector will not know that where the defect is going to come, which place of the garment defect is going to come. Next is no plenty points are recorded for minor defects. Major defects are classified as below. So we are not going to give any penalty point for the minor defects. And what are the list of the major defects are there is mentioned here. I will also going to tell about those major defects. Major woven fabric defects such as sloughs, holes, missing yarns, conspicuous yarns, variation, end out, soiled yarn and wrong yarns. These are the major woven fabric defects are. Then we will talk about the major knitted fabric defects. These are the mixed yarn, yarn variation, runner, needle line, barre, slub, hole, press off. These are the major knitting fabric defects. And some major dyeing and printing defects are print out, like the something has come out, like the whatever the print has given, it's coming out. Dye spots we can find the dyeing. Then machine stop, somewhere the machine has been stopped, so line is there, that machine stop line is there. Color smear or shading, if the shading variations are there, so that is also come under the major color defect in the fabric, dyeing defect or printing defect in the fabric. So how we will count these? These are, so far we have discussed about these are the parameters are there. Before we have to take these things before, for the measurement, for the checking of the fabric. Now we will do the acceptable point count. This method of acceptance uses a projection of total defects based on number of defects found in an inspection of a sample. For example, the points are calculated on 100 square yard basis. To calculate the average points 100 square yards for the shipment, the calculation says like the total points counted for all rolls inspected multiply by 39 into 100 divided by total meters inspected, and further it is divided by cut table width in inches. So up to 40 points per square yard of the fabric is acceptable defect rate. More than 40 points, if we are facing the more than 40 points, then that particular fabric is not supposed to, we are not supposed to use as per the 4-point inspection system. After quality control for raw material that we discussed about the fabric, the next one is quality control for spreading and cutting. The spreading, though not considered an important operation during garment manufacturing and is normally carried out manually without the supervision of cutting master, but is a critical point. The post-sewing measurement defects found in a garment can in most cases be attributed to incorrect spreading and cutting. While spreading, the quality assurance inspector to check the fabric lay for the following defects. In case of marker, always compare the marker with the original pattern. This is required, like if the marker is made, so we should always compare with the marker with the original pattern, that whether all the patterns are there, whether the pattern tracing is proper or not. So this the grain line of the marker, grain line of the pattern has been maintained or not. So marker making is to make sure that all parts of a particular garment appears on the marker. Check for the small parts like the collar, cuffs, and their presence in the pairs. Basically what happens, these small parts, like for shirt, small parts are pocket, we have the collars, we have cuff. So these small parts, sometimes in the marker, these small parts are left over, and we have made the marker and cutting has been done. Then after we realize that the smaller parts, like these are the smaller parts, the parts are not there. Like a pocket, if the pocket has missed and pocket comes in the E zone of the garment, so in this particular case, the problem happens like if you are recutting the same pocket with the another bundle, another roll of the fabric, they may have the shade variation, the region of the shade variation, and we cannot afford to have the shade variation in the A zone of the garment. So due to that reason, maybe the whole garment can be rejected. That can also happen. So like the collar also comes under the E zone, and then after the collar has some problem, like the pairs of the collar is not there or pairs of the cuff is not there. In that case, the problem can happen, and this may create a big quality issue. So these smaller part has to be checked before we should move further. Then marker placement is also important, to check that marker is placed on the spread with the edge parallel to the selvage of the piece goods. Like how the marker has been placed, whether it has been placed parallel to the selvage of the fabric for the piece good. We have to also ensure that all cut parts will be completed. Whether the cut parts are there, whatever the cut parts are there, it has to be completed. The next one is the table marks. Check the table for all table marks. Allow no minus tolerance for splicing, a minimum of 1 inch of overlap. So we should always check about the table marks, whether the splice marks has been given. For splicing, we have to overlap the fabric. So what is the overlap is there? These all things has to be checked before during the spreading process. Then markers has to ensure that the marker is not creased, is not damaged, and is not overlap parts. Parts should not be overlap in the marker. The marker should not be creased. It should not be damaged. These all things has to be checked also. Then marker blueprint. Make a random check of some measurements in the marker. Sometimes while making a blueprint of the marker, unknowingly the marker gets pulled or size got distorted. Sometimes we are making the blueprint of the marker, that time by some issue happens, like the marker is either size got distorted or marker got pulled. So we should check before in the blueprint of the marker also whether the sizes of the marker has been made has been as per the pattern or not, and marker is not should not be get pulled. Then spread height, we have to ensure that the height of the spread is at least 2 inches less than the cutting blade knife. In case of the nets, to ensure that ply height is stable. So the height of the spreading has to be, the table has to be, also we have to take care about the if we comparable to the what is the height of the machine head blade height. The height of the spread should not be more than the machine height, and we have to give the some allowances for the movement of the knife. The narrow goods, after completion of the spread, check the far edges of the spread to see that all plies extend beyond the marker line. The tension and creasing, ensure that there is no artificial or excessive tension due to a very tight spread. Also check randomly for any creasing of the fabric. They should not have any creasing in the fabric, and the fabric tension should not be there. We should always get the fabric tension released before it has to come for the spreading. Especially this problem happens in the knitted fabric, like the rib fabric, and maybe we have the jersey fabric. The jersey fabric and rib fabric, if during the winding of the roll, there are some tensions can come. It has rolled wind tightly. Then what problem happen after the spreading? Once we have done the spreading, after the cutting, we will find like that due to tension, the size has been got size, large size may become near to medium size. So size jump may happen because of if the tension is there in the fabric. So after the cutting, maybe we will find like that size has been reduced further, and we have the measurement problem. So it's always advisable to keep the fabric in, especially the knitted fabric, and the fabric have the lycra or fabric has the spandex. Those fabric we should keep in open form for around maybe overnight or 8 hours or maybe 4 hours, depends on the type of the fabric, so that they should not have any tension in the fabric. They should not have any further shrinkage in the fabric after cutting. Then we are talking about the leaning. Basically we have to check the carefully to ensure that one edge of the fabric is square to the tabletop. It should be square of the tabletop. Visually inspect to ensure the element to the edge with the tabletop. Next is the count. Check the count after completion of the spread, and before cutting, count all plies of both ends. There is no tolerance. The counting of the complete ply has to be done. Check has to be done that how many plies we have spread. Suppose we are spreading 120 plies. So all 120 ply count should be there. All pattern count should be there. All how many we are getting, the how many markers, that count has to be done. So these all problems, these are the problems can occur during the cutting, during the spreading. So these all has to be very sure about, these problems should not happen. So we have to make sure that these problem has to be taken care during the spreading itself. Here often changes are being made to markers to adjust certain production problems. Under no circumstance we should do such an act. What happens? The problem is we are making the changes in the marker. Even the pattern also we are making some changes in the pattern, and to adjust the whatever the production problem is there, we are making the change in the marker. But we should never do that. The problem happens later on if the same repeat style has come, or maybe we are doing the same style after some time. So maybe this problem may have the another issues, uh, uh, another we will face the another problem. So under no circumstances we should do such an act. In case of such a situation arise, all changes should be made in consultation with the company merchandisers and quality inspectors. We should not, spreader should not do the changes by his own. Even cutting manager should not do the changes by own. If the changes has to be done, it has to be make into the knowledge of merchandiser and quality inspector. There should not be any change required in the pattern marker. A new pattern, if there is any change is required in the pattern marker, the pattern marker should be developed. The new pattern has to be developed. We should not alter the old pattern. The new pattern has to be developed, and under no circumstances we should change the same marker. Also, under no circumstance we should do any tolerance to be allowed in the spreading or cutting, as a defect in the spreading cutting would lead to accelerate defect while sewing. The spreading inspector is to inform the spreading master and cutting master of the irregularities in the spreading and ensures that corrective steps are taken. In case of re-spreading or redevelopment of the marker, the inspector should decide on the date along with the spreader and inform the company quality inspector. So now we will move further for the inspection guidelines. What are the inspection guidelines are there for during the spreading? So always try to inspect without disturbing the cut blocks. So these inspection guidelines we are coming after the spreading, we are coming on the cutting. Always try to inspect without disturbing the cut block. This is essential in case the particular piece has to be recut. So if the recutting has to be done, mostly we are doing the recutting for the checks and striped fabrics. For if the fabric has to come for the recutting, it has to move to recutting table. So we should always try to not disturb. We should always we should be very firm about this particular thing, that we should not disturb the cut blocks. Cut blocks has to not disturb, because maybe it will come for the recutting. We should also not disturb the order of the cut pieces as they are not yet to be numbered. So because numbering has not done before the numbering, because each and every ply or each and every panel has to be go for the numbering. So we should not disturb the order of the cut pieces before it has gone for the numbering. Sometimes manufacturer, for reason of saving time, pass on a decision of recutting of the cutting room to trimming or snipping in the sewing room. Such a practice leads to added cost at the sewing room for trimming of each and every piece in comparison to it being cut in bulk in cutting room. So we should always take care about this thing. Cutting department should at all times give ready cut pieces to the sewing room. This refers to all parts being cut exact as per the marker. Then fabric fault must be marked and defective parts replaced. We have to make sure that pattern pieces must be correctly placed on the fabric. Then provision, we should always give the provision for matching stripes. All pieces must be correctly identified by style and sizes, because the pieces, the identification is very important for the size and style. So that's why we are giving in the numbering sticker itself, the size and style at least has to be mentioned. Parts must be fully marked within the defined layer width. Line definition must be satisfactory, neither too thin or nor too thick. The whatever the line we are giving, that has to be very not thick, not thin also. It should not be so thick that it is, it may create the extra allowances will become in the whatever the parts we are going to cut, and it should not be thin also, so that it will not be visible. Defective parts must be replaced. Also defective parts must be replaced. In case of the fusing, check of bubbles, incorrect fusing, etc. If the fusing has to be done, so we should always check the bubbles in the fusing. There should not have any bubbles in the fusing. There should not have the incorrect fusing. Bunding should be checked, and sample of the bundle number, style number, etc. it has to be checked. So now we have the number of parts to inspect. It is always recommended that at least 50% of garment parts in the marker be inspected. Parts cut on different types of cutting machines to be taken in the ratio 1:1. This is recommended so that it takes of both the small and big parts of the garment. For example, the big parts of a polo t-shirt are cut on a straight knife, and the small parts are cut on band knife. For purpose of inspection, the parts chosen for size M would be front, back, sleeves, that is for straight knife, placket, yoke, that is half moon, cuff will be done on the band knife. In case of all parts are cut on one type of the cutting machine, the parts selected should be combination of both big and small parts. Also, in case of there is a lot of measurement problem observed in the sewing room, it is advisable that all garments parts be cut in cutting room. In case of particular problems in measurement under or exceeding tolerance, as evidence from the past records, so the company quality team should check all the garment parts in the cutting room as per recommended system. Then next is basically the selection of the garment cut parts. How we are going to select the garment cut parts for quality inspection. The this combination of big and small parts, garment parts should be inspected. The garment parts lying under the selvage and the ends should always be inspected. While inspecting a garment part, 3 pieces should be taken from the stack in order to compare top, middle and bottom. So what happens, if you have done the cutting, so top ply, maybe we have done the 100 pieces, 100 plies cutting. So first, like the topmost ply, that is 100th ply, then 50th ply and first ply. Those all three has to be inspected, because to understand that all 3 plies are having the same measurements, should not be up or down. So basically, sometimes the problem happens if those ply we have used the slanted knife. We have during the cutting, sometimes the cutter used to slant the the knife. In that case, the smaller parts may become bigger or smaller than maybe from the top part, or top part maybe become smaller or bigger than the smaller part. So these has to be checked at just after the cutting. Then so many defects are there which has to be classified, which has to be mentioned in the spreading room itself. About the miscut, that is the check for the miscut or for the failure of the cutter to split the line, that is tolerance is plus and minus. Normally the tolerance used to be plus and minus 1/16 inch. Matching ply, that is the check the top ply with the bottom ply, tolerance is around plus and minus 1 inches, 1.5 inches, sorry 1/8 inches. Then rack cutting, this is a judgment defects. For certain parts such as pockets, collars, rack cutting can be critical problem, whereas for some parts like front of the defect would be less severe in case of the rack edges are not so severe. Notches, the notch location should be checked for placing the pattern over the top ply. Tolerance is plus and minus 1/8 inch. Check pattern to compare the marker to ensure that the marker was correct. The slant knife, to check the top ply and the last of the slant knife. This occurs while cutting when the knife blades tilts. This result is a difference in sizes throughout the ply height. Then we have to do for the measurement check. The tolerance for straight knife is 3 millimeter, tolerance for band knife is 2 millimeter, and tolerance for die cut is 1 millimeter. Then quality inspector should try and access the wastage of the fabric in cutting. In case of where excessive wastage is found, that is the wastage, that is the end wastage, the inspector to make a note and discuss with the senior manager. So after this cutting, next we are moving for the quality control in sewing. This system describes how monitoring of quality is an ongoing process and is not merely a control mechanism. The approach of this method is to proactive rather than corrective. The entire system revolves around building quality into the garment, not inspecting quality into the garment. There are some inspection guidelines for the sewing. The sewing defects begin and end with operator. It has been noticed that in most cases the operator is not aware of what is required from him and her in terms of stitching quality. It is just imperative that one sealed sample as per the order, correct fabric trims, adhesive will available and easily accessible to the all the operator on shop floor. So one sealed sample should be easily available for a all operator, which should be there in the line, which can be the reference for each and every operator. In case of certain garment parts that required a skillful operation or for critical operation, the operator should be given a sample of the same for their ready reference. The mock sample, this is basically the mock sample. The mock sample has to be made before the start of the production, and it has to be hanged on each and every machine for the ready reference for the operator, so that in case of any problem, in case of any confusion, in case of any clarification, the operator can always refer that particular sample for that particular operation. So the broad objective of this is to, there should not be any legitimate reason of someone not knowing what is happening. A three-part system is suggested to be used in sewing room. The component of three-part systems are in-process sampling, 100% inspection, and quality audit. First, we will discuss about the in-process sampling. Sampling is more economical and feasible than checking everything. A proper sampling system can give results that is closely representative of actual situation. Attention can also be focused on area where defects are being produced. The objective of in-process samplings are maintaining a steady and tight control over all operators and concentrating attention where poor quality is being produced. These inspection guidelines are, the inspector should be a person not directly responsible for a production. The inspector should be adequate knowledge of the garment being produced in terms of tolerances, stitching details, workmanship quality required, and manufacturing standard for the garment. All operators, if possible, should have a quality specification sheet at their workstation which describes the parts or part they have to stitch together. So what part has to be stitched together, what are the parts, so these all descriptions should be there with in front of the operator. The workmanship quality pertaining to the particular part, that is a straight seam or a curved one, like what are the the quality, workmanship quality is required in that particular seam, whether it's a straight seam or it's a curved one. Any quality problem that are likely to occur at their particular operation. If any quality problem which is likely to occur for that particular operation, that has to be mentioned. The tolerance pertaining to the sewing operation. If there is tolerance, well, how much tolerance is there? Suppose the operator is doing the operation of side seam attach. So side seam attach, what is the tolerance for side seam attach? How much tolerance is acceptable? So that also is mentioned there. This information should be available to the operator at each and every workstation where it is easy to read and should be it should be legible neatly and with required in the local language. If required, we should write in the local language so that each and every operator will understand in that particular language what is expected. Along with the mock sample, we are giving the reference sample. We discuss about the one reference sample should be there in the line, so that it will be easier for each and every operator who can refer that particular reference sample. Now, second thing we discuss about that mock sample. For every operation, we should have the mock sample, and that mock sample has to be for that particular operation. For each and every operation, every machine will have the mock sample which can be easily referred by the operator. Third thing we discuss about that, for that particular sample, we should know the and how. All operators, it should be in written format about the straight stage, about the curve stage, about the tolerances in that, about the SPI for that particular operation, about the quality parameters, like the how much what are the do's and don'ts are there. So these all things has to be mentioned, ready available to the operators. Preferably it should be in the local language, so that each and every operator will understand that, can go through that and will be comfortable before he will start the operations. The main features of the systems are, we talk about the main features of the systems. The inspectors move around the sewing room, visiting operators or operations at random. In this particular sampling, inspector moves around the sewing room. They visit the operators and operations at random. He or she take a quantity of garment, whatever the quantity of the garment is there. Usually he used to take a bundle. From the bundle, he or she selects given number of pieces or parts of a garment and checks them against the specification of the operation concerned. So he will check the what is the specification is there, against the specification what is the operation is concerned, and if the parts are duplicated as in the two sleeves, two parts corresponding to the one garment, the finding of the checks are recorded on the sampling record. The number of garments selected for the checking should all be laid down for each factory. So then, depending on the result of the check, the whole bundle is accepted as being of satisfactory quality or rejected as being unsatisfactory. If it is if this bundle has been accepted, then they will be marked as a satisfactory quality. If it is rejected, it is mentioned that unsatisfactory quality. The rules which decide what constitutes a satisfactory or unsatisfactory bundle are laid down as a part of factory system. Accepted bundles should proceed to next operation, and rejected bundles are passed to the supervisor for the action. So after the inspector has done the sampling, they have done the quality inspection, the bundle has to be sent for the whichever is accepted is there, it will be passed to the next level, and which is rejected, it will go to the supervisor, so to take the action for that particular problem. When the supervisor gets a rejected bundle, he or she assesses the problem and instruct the operator to repair the defect and check the rest of the bundle. The supervisor also seeks rectifies, if possible, the cause of the defect. The supervisor is the responsibility of the supervisor, who rectify, who understand, who try to find out what is the cause of the defect, and accordingly he used to address that particular issue to the operator. The operator who has shown the rejected bundle now comes under a procedure called clearance, which brings the operator under a close scrutiny than the usual random sampling. So the operator having the problem, the bundle, whichever the rejected bundles was there, that particular operator used to come under the scrutiny, closer scrutiny, and then the usual random sampling. This continues until the operator is cleared by the steady good production. This scrutiny will go off till the time operator will not do the correct thing. So once he will start or she will start doing the correct thing, this particular scrutiny will go off, will be continue till the time he will not clear the steady bundles. Under clearance of the inspector returns to the operator, After a short interval, takes a recent completed bundle and bundles. So operator again, inspector again check the bundles. These bundles are checked and accepted for the or rejected using the same rule as for the random sampling. The operator is cleared when a given number of bundles are accepted. This number is called clearance number. During clearance, accepted bundles are passed on to the next operator, and any rejected bundles are given to the supervisor for action as with the faulty. So these process used to keep repeated by the inspector. He used to pass the bundle if to the next operator. If some problem comes, he used to give the bundle to the supervisor for taking action. When operator has cleared, he or she is not checked again until her name comes up in the normal random sampling procedure. In this way, the inspector keeps checking operator whose quality is bad while still going around the factory checking other operators. Of course, neither the inspector nor the supervisor is expected to calmly allow an operator to remain uncleared for the quality for a long. The supervisor will speak to the operator on the first rejection and should take urgent action after the second rejection to find out what is wrong and cure it. So some problems may be there, maybe the problem may be in the machine, the problem may be in the material also. The problem can be driven by the the operator itself. So this can be done with the using the fishbone diagram also. Fishbone diagram, in the fishbone diagram, it will be mentioned like that probable reasons for that particular problem. And then each and every reason will be taken care by the supervisor to understand, to satisfy that which are the reasons, which is the major cause due to that this problem is happening. So it has to be done. So an important part of the system is that no time does the inspector returns the work directly to the operator, only supervisor returns the work for repair. So he or she is responsible for her section and should see all work that is being returned. He or she will then judge the reason for the defect and take the appropriate action dealing with the operator, machine or cut work, etc. The ideal situation is where the supervisor feels that the inspector is there to help her by finding quality problem for her before they become serious. And when installing a sampling system, this attitude must be introduced from the start. The supervisor should be educated to see the inspector as a helper, an extra pair of eyes, not someone there to create trouble. It's not to create the trouble, it's always to vigilant. The person should be very vigilant so that if the problem should not arise again. Unless the supervisor inspector cooperates, the system will not work. So that both the cooperation between the supervisor and inspector both are required. Apart from this relation with the supervisor, the inspector must be able to understand what he or she is looking for, interpret quality specification, have sufficient confidence in her own judgment to insist that a mistake is a mistake. Even when the supervisor says that is not too bad, it can go on. Then we discuss about the parameters. Different parameters are there. There are 4 parameters that needs to be defined before starting in process sampling. These parameters are there. Lot, that is collection of garment parts from where the sample is to be taken. That is maybe one bundle. Sample size, the number of the garment or parts to be taken for inspection from the lot, that is 6 garments from one bundle of 25 pieces or something like the sample size has been taken. So how many samples, like from 20 pieces, 25 pieces, he has selected 6 garments. Then accepted number, the number of the faulty garments parts that a sample may have without the entire lot being rejected, that is 0 out of 6. Suppose out of 6, if a 0 defect is there, the garment, even 1 defect is there, the garment parts is rejected. So that's called acceptance quality level, acceptance number. And then clearance number, the number of the lots that must be accepted in succession to take operator out of the clearance procedure, that is 1 lot. The next, after the sampling method, we are talking about the examination. 100% examination is the process to check all stitched garments and some garment parts in the production. 100% examination should be done within the line and at the end of the line. The major objective of 100% examination to prevent defective garments from being passed. The repair faulty garments and remove the cause of the defects. It is likely that after the in-process sampling, some faulty garments will be produced. The objective of 100% inspection is to prevent faulty garments being passed as perfect. Examination is a stage in production sequence and is normally regarded as an operation. Most factories examine at the end of making operations and sometimes at the end of finishing. In other factories, examination is combined with thread trimming. On one hand, the trimmer is going over the seams anyway, and he or she may as well examine at the same time, and on the other, trimming and examining call for different type of the operators. Some operators tend to trim and force to examine and forget to examine, and whether or not these operations are combined depend on personnel of the factory. There are some examination points are there. For economical reason, there should be a few examination points as possible. On the other hand, for easy repair, examination points should be placed before any operation which overshoes an earlier one. To reconcile these opposing objectives, it should be considered how many defects are actually being produced by each operation, how many are found at examination point, and whether or not these defects will show in the finished garments. The usual position of inline examination point is after a critical component has been made before attaching it to the main garment. For example, like to make a shirt collar. So examination guideline, that is 100% examination inspection within the line at the end of the line. The inspector should be trained to inspect. This implies that there should be a pre-defined set of action that he or she undertakes to examine each garment parts for visual measurement and workmanship. Examination tends to a boring job, and any inspector can become mesmerized after a while and simply not see what he or she is looking at. To help avoid this, an operation description must be written for this job detailing how inspector checks the garment. The inspector should be positioned within the line similar to a sewing operation. His and her workstation should be adequate large to handle the garment parts that is to be checked, and the reports and other work aids to be placed that he or she needs to carry out for the inspection. The inspector should be adequate authority not to proceed a bundle to the next operation in case fault are found. He or she under no circumstance should be harassed by operator to pass on the bundle just because the production target for the day has to be met. So these are the, that's why we discuss about the inspector should not have the target for the production. Inspector should be independent. So that is that way it can be done for the 100% inspection. Now after 100% inspection, we are moving for the quality audit. Quality audit is an examination of small number of garments from finished stock from sewing. These are taken as a representative of the quality going for finishing room. At end line, checkers are audited individual 4 times a day to ensure a control on checking efficiency of end line checkers. The major objective of this particular quality audit is to check the other parts of the system to obtain figures which can be compared with the figures of in-process sampling and final inspection, giving comparison of the effectiveness of above two systems. To also look at the garment from the customer point of view and analyze the result. Some inspection guidelines are there for the quality inspection. The auditor for the sewing floor should be qualified and experienced quality controller and should be able to check a garment thoroughly as per buyer specification. The auditor should himself randomly pick up the garments from each checker's past pieces. These pieces should not be given him by the supervisor or any other personnel. He should do audit of each checker at least 4 times a day in order to get a representative checking efficiency of the checker. The formula for checking efficiency of checker is basically 100% checking DHU. DHU stands for defects per 100 unit, multiply by 100. It will be the whole will be divided by 100% inspection DHU plus quality audit DHU. For the washing finishing audit, emphasis should be given to areas affected by washing finishing, that is trimming, holes, fraying at the collar, etc. After fabric raw material quality checking, then spreading, cutting, quality control, and then sewing, the next one is quality control for finishing. What are the quality control measures we have to take in finishing? It is recommended that 100% inspection and an audit be carried out either after washing or finishing. In case of wash pieces is rigorous or a special wash is being done, it is advisable to check all garment after washing. It is recommended that the garment be slightly ironed and then inspection to be carried out, because if the garment is crushed, then it's very difficult to do the inspection. So initial inspection has to be done after the initial press. Then after, if the garment has been passed from the initial inspection, then the final pressing can be done. So that they should not have the initial inspection, also we should not have the major crush. Then we talk about the 100% inspection. The major objective is for the 100% inspection is to identify defects that occur after washing. The few inspection guidelines are there for the for this inspection. That emphasis should be on those areas that are affected by washing, that is button attachment, fraying of the collar, etc. Inspection could be combined with thread trimming in case of normal washes, and it is recommended that garment be ironed lightly, that is a quick iron, before inspection. This eases out the creases from the garment and aids the inspector in identifying defect. Then we are having the finishing quality audit. Daily quality audits are recommended to be conducted to ensure consistency in quality. It is acceptable to inspect a small number of garments thoroughly. However, under no circumstances should the audit missed or its results overlooked. Finishing quality audit is an examination of a small number of garments passed by checkers from finished stock. These are taken as a representative of the finished quality going to customers as a first. The objective of this is basically to check the other parts of the system, to obtain figures which can be compared with the figures of 100% final inspection, giving comparison of effectiveness of the above system, to look at the garment from customer's point of view and analyze the results. The inspection guidelines are the auditor for the checkers audit should be a qualified and experienced quality controller and should be able to check a garment thoroughly as per buyer's specification. The auditor should himself randomly pick up the garments from each checker's past pieces. These pieces should not be given to him by supervisor or any personnel. So auditor has to pick the piece by himself or herself. He should do the audit of each checkers at least 4 times a day in order to get a representative checking efficiency of the checker. And we have discussed earlier also about the formula about the checking efficiency to check the fitting efficiency. For the washing finishing audit, emphasis should be given to areas affected by washing or finishing, that is the trimming, holes, fraying. We have discussed on that particular thing. quality audit is an everyday process and should be undertaken without fail. Then after this one finishing, we have the pre-shipment quality audit. A quality audit is recommended to follow after packing of the goods begin. The audit should be conducted daily to ensure that the shipment is of consistent quality. Quality audit is an examination of small number of garments from finished stock. There are taken a representative of the finished quality going to customer as first. The objective is to check the other parts of the system to obtain figures which can be compared with figures of in-process sampling and final inspection, giving comparison of effectiveness of the above two systems to look at the garment from the customer point of view and analyze the results. The inspection guidelines are: the auditor for a quality audit should ideally be from the senior management and should try scrutinize the product from buyer's point of view. The auditor should himself randomly pick up the garment to inspect from the day's production. These pieces should not be given to him by supervisor or any other personnel what we discuss. So specifically the following points must be checked for conforming with standard. Folding and packing guidelines available in the separate section. So the carton size, oversize of the cartons are not allowed. The carton quality, carton gross weight, net weight, carton tape, carton not be factory vendor, carton does not have factory vendor's name printed on them. So these are the few points are there which has been mentioned for the checking of the cartons and all. So we have already discussed about the, so far we have discussed about the fabric store, raw material checking, we have quality control in raw material, we have discussed about the quality control in sewing, we have discussed about the quality control in cutting and sewing, then finishing, then packing. So these are the complete manufacturing system. These are the area where the quality has to be maintained properly, and each and every stage quality has to be ensured. We have to ensure the quality has been passed through each and every stage, because later on once the garment has been made, we cannot do anything. We can only do the postmortem. Once the garment has been made, we have option with the reject the garment, or if you are going with the repair of the garment, it's very time consuming process. And the industry nowadays, where the timeline has been squeezed, the total time of the shipment time or total production time has been further squeezed. So there is no time for the repair also, and there is no time to reorder the fabric also. So it becomes a do and die situation for a manufacturer. If pieces are not going on time, the complete garments or complete order is not going on time. So quality is utmost important for any manufacturing setup, especially for the garment manufacturing setup, which is the manpower driven industry, where each and every stage the quality has to be ensured. Thank you very much. Finally, this module provides useful suggestions and ideas that you can employ to ensure quality during the manufacture of garments. Spreading is not considered as important operation during garment manufacturing. It is normally carried out manually without the supervision of cutting master and is a critical checkpoint. A post-sewing measurement defects found in a garment can in most cases be attributed to incorrect spreading and cutting. While spreading, the quality assurance inspector should check the fabric lay for following defects. In case of a marker, always compare the marker with the original pattern. Ensure that all parts of a particular garment appear on the marker. Check for the smaller parts such as collars or cuff for their presence in pairs. Check that the marker is placed on the spread and edge is parallel to the selvage of the piece goods. Ensure that all cut pieces are complete. Check the table for all table marks. Allow no minus tolerance for splicing. that is a minimum of 1 inch of overlap. Ensure that the marker is not creased, damaged or has overlapped parts. Make a random check of some measurements in the marker. Sometimes while making a blueprint of the marker, unknowingly the marker gets pulled. This distorts the sizes. Ensure that the height of spread is at least 2 inch less than the cutting blade knife. In case of nets, ensure that ply height is stable. After completion of the spread, check the far edge of spread to see that all plies extend beyond the marker line. Ensure that there is no artificial or excessive tension due to a very tight spread. Also check randomly for any creasing of the fabric. Check carefully to ensure that one edge of the fabric is squared to the tabletop. Visually inspect to ensure the alignment of the edge with the tabletop. Check the count after completion of spreading and before cutting. Count all plies at both ends. Ensure there is no tolerance. Often changes are made to markers to adjust certain production problems. Under no circumstance should such an act to be undertaken. In case such a situation arises, all changes should be made in consultation with merchandiser of the company or quality inspectors. Should there be any change required in the pattern or marker, a new pattern or marker should be developed. Under no circumstance should changes to be made on the same marker. Under no circumstance should any tolerance to be allowed in the spreading or cutting, as such a defect would lead to accelerated defects while sewing. The spreading inspector should inform the spreading master or cutting masters of the irregularities in the spreading and ensure that corrective steps are taken. In the case of re-spreading or redevelopment of the marker, the inspector should decide on the date along with the spreader and informed quality inspector of the company. When inspecting, always try and inspect without disturbing the cut block. This is essential in case of the particular piece has to be recut. Don't disturb the order of the cut pieces as they have not yet been numbered. These are some of the important inspection standards to be followed. Number of parts to inspect, selection of garment cut parts, defect classification. It is recommended that at least 50% of the garment parts in marker to be inspected. Parts cut on different types of cutting machine are to be taken in the ratio of 1:1. This is recommended so that it takes care of both the small and big parts of the garment. For example, the big parts of a polo shirt are cut on a straight knife and small parts are cut on band knife. For purpose of inspection, the parts chosen for medium size would be front, back and sleeve for the straight knife and placket, yoke, half moon, cuffs for the band knife. In case of all garment parts are cut on one type of cutting machine, the parts selection should be combination of both the big and small parts. In case there are a lot of measurement problem observed in the sewing room, it is advisable that all garment parts to be checked in the cutting room. In case of particular problem in measurements such as under or exceeding tolerance, as evidence from past records, quality team of a company should check all the garment parts in the cutting room as per the recommended system. Defects can be classified in a number of ways. Check for miscut or for the failure of cutter to split the line. This is a judgmental defect. For certain parts such as pockets, collars, ragged cutting can be a critical problem. Whereas for some parts like the front, the defect would be less severe in case of ragged edges are not too severe. The notch location should be checked by placing the pattern over the top ply. Defects can be further classified in these ways: check pattern, slant knife, measurement checks, excess wastage of fabric. Compare the pattern to the marker to ensure that the marker was correct. Check the top and the last ply for the slant knife. This occurs while cutting when the knife blade tilts and results in a difference in sizes throughout the ply height. Tolerance for straight knife is 3 mm, band knife 2 mm and die cuts 1 mm. The quality inspector should try and assess the wastage of fabric in cutting. It is a situation where excess wastage is found. For the example, and uses the inspector should make a note and discuss it for the senior management. Quality control sewing. This system describes how monitoring the quality is an ongoing process and not merely a control mechanism. The approach of this method is to be proactive rather than corrective. The entire system revolves around building quality into the garment and not inspecting quality into the garment. Sewing defects begin and end with the operator. It has been noticed that in most cases the operator is not aware of what is required from him or her in terms of stitching quality. It is thus imperative that one sealed sample, that is a sample as per order, correct fabric and trims, be available and easily accessible to all operators at the sewing floor. In case of certain garment parts that require a skillful operation or for a critical operation, the operator should be given a sample to the same for their ready reference. The broad objective of this is that there should never be any legitimate reason for someone not knowing what is happening. The three-part system is suggested to be used in the sewing room. The components of three-part systems are in-process sampling, 100% inspection, quality audit. Sampling is more economical and feasible than checking everything. A proper sampling system can give results that are closely representative of actual situation. Attention can also be focused on areas where defects are being produced. The objective of in-process sampling are maintaining a steady and tight control over all operators and concentrating attention where poor quality is being produced. The inspector should be a person not directly responsible for the production. The inspector should have adequate knowledge of the garment being produced in terms of tolerances, stitching details, workmanship quality that is required and manufacturing standard for the garment. The quality inspection sheet should describe the parts or parts that are to be stitched together, the workmanship quality pertain to that particular part, for example, a straight seam or a curved one. Any quality problem that might occur at their particular operation, the tolerance pertaining to their sewing operation. This information should be available to operator at their workstation where it is easy to read. It should be legible, that is, it should be neat and if required in the local language. It is responsibility of the supervisor that each operator understand his or her specification clearly before production starts. Depending on the results of the check, the whole bundle is accepted as being of satisfactory quality or rejected as being unsatisfactory. The rule which decide what constitutes a satisfactory or unsatisfactory bundle are laid down as a part of factory's system. Accepted bundle should proceed to the next operation where the rejected bundles are passed to the supervisor for auction. Checking an operator's quality. When the operator has been cleared, he or she is not checked again until her name comes up in the normal random sampling procedure. In this way, the inspector keeps checking an operator whose quality is bad while still going around the factory checking other operators. Of course, neither the operator nor the supervisor is expecting to calmly allow an operator to remain uncleared for quality for long. The supervisor will speak to the operator on the first rejection and should take urgent action after a second rejection to find out what is wrong and cure it. An important point of this system is that at no time does the inspection return the work directly to the operator. Only the supervisor returns work for repair. The operator is responsible for that particular section and should review all work that is being returned. The operator will then judge the reason for the defect and take appropriate action dealing with operator, machine or cut work. The supervisor and the inspector. The ideal situation is where the supervisor feels that inspector is there to help her by finding quality problem for her before they become serious. This attitude must be introduced from the start when installing a sampling system. The supervisor should be educated to see the inspector as a helper, an extra pair of eyes, not someone there to create trouble. Unless the supervisor and inspector cooperate, the system will not work. Apart from this relationship with the supervisor, the inspector must be able to understand what is being looked for. The inspector should also interpret quality specification and have sufficient confidence in her own judgment to insist that a mistake is a mistake. Even when the supervisor says that is not bad, it can go on. There are 4 parameters that need to be defined before starting in process sampling. The collection of garment or parts from where the sample is to be taken, the number of garments or parts to be taken for inspection from the lot. For example, 6 garments from one bundle of 25 pieces. The number of faulty garments or parts that a sample may have without the entire lot being rejected. For example, 0 out of 6. If there is even a 1 defect piece in the sample, the entire lot will be rejected. The number of lots that must be accepted in succession to take the operator out of clearance procedure. For example, 1 lot. 100% examination is the check to all stitch parts and some garment parts in production. 100% examination should be within the line and at the end of the line. The objective of 100% inspection is to prevent defective garment from being passed, repair faulty garments and remove the cause of the defects, prevent faulty garments from being passed as perfect. It is likely that after the in-process sampling, some faulty garments will be produced. The examination stage. Examination is a stage in the production sequence and is normally regarded as an operation. Most factories examine at end of making operations and sometimes at the end of finishing. In another factory, examination is combined with thread trimming. On one hand, the trimmer is going over the seams anyway and you may as well examine at same time. On the other hand, trimming and examine call for different types of operators and some operators tend to trim and forget to examine. Whether or not these operations are combined depend on personnel of the factory. Examination points. For economic reason, there should be a few examination points as possible. On the other hand, for easy repairs, examination points should be placed before any operation which oversees an earlier one. For reconcile these opposing objectives, it should be considered how many defects are actually being produced by each operation, how many are found at the examination point and whether or not these defects will be visible in the finished garments. The usual position for inline examination points is after a critical component has been made before attaching it to the main garment. For example, after making a shirt collar. Inspection guidelines. The inspector should be trained to inspect. This implies that there should be a predefined set of action that is undertaken to examine each garment or parts for visual and measurement and workmanship. Examination tends to be a boring job and many inspectors can become mesmerized after a while and simply not see what is being looked at. To help avoid this, an operator description must be written for this job, detailing how the inspector should check the garment. The inspector should be positioned within the line similar to a sewing operation. The inspector should have a workstation that is adequate large to handle the garment parts that is to be checked, as well as the reports and other work aids that are required to carry out the inspection. The inspector should have adequate authority not to send a bundle to the next operation in case fault are found. Under no circumstance should an inspector be harassed by the operator to pass on the bundle just because the production target for the day has to be met. Quality audit is an examination of a small number of garments from the finished stock from sewing. These are taken as representative of quality that is going to be finishing room. At end line checkers are audited individually 4 times a day to ensure control on checking efficiency of end line checkers. The objectives of a quality audit are to check the other parts of the system, obtain figures which can be compared with figure of in process, sampling and final inspection giving comparisons of the effectiveness of above two systems. Look at garment from the customer's point of view and analyze results. Inspection guideline. The auditor for the sewing floor should be a qualified and experienced quality controller and should be able to check a garment thoroughly as per buyer's specification. The auditor should himself randomly pick the garments from each checker's past pieces. These pieces should not be given to him by supervisor or any other personnel. He should audit each checker at least 4 times in a day in order to get a representative checking efficiency of the checker. This is the formula for checking the efficiency of a checker. Checking efficiency is equal to 100% inspection DHU into 100 divided by 100% inspection DHU plus quality audit DHU. For the washing or finishing audit, emphasis should be given to areas affected by washing or finishing such as trimming, holes and fraying at the collar due to washing. Quality audit is an everyday process and should be undertaken without fail. Quality control in finishing. It is recommended that 100% inspection and an audit to be carried out either after washing or finishing. In case the wash process is rigorous or a special wash is being done, it is advisable to check all garments after washing. It is recommended that the garment should be slightly ironed and then inspected. The main objective of 100% inspection is to identify defects that occur after washing. When inspecting, emphasis should be on those areas that are affected by washing such as button attachment and fraying of collar. The inspection could be combined with thread trimming in case of normal washes. It is recommended that the garment be ironed lightly before inspection. This eases out the creases from the garment and aids the inspector in identifying defects. Finishing quality audit. Finishing quality audit and examination of a small number of garments passed by checkers from finished stock. These are taken as representative of the finished quality going to customer as first. It is recommended that daily quality audits are conducted to ensure consistency in quality. It is acceptable to inspect a small number of garments thoroughly. However, under no circumstance should the audit be missed or its results overlooked. The main objective of the finishing quality audits are to check the other parts of the system and to obtain figures which can be compared with figures of 100% final inspection. This will give comparison of the effectiveness of above system. Finally, it allows an inspection to be done from the customer's viewpoint and to analyze results. Inspection guidelines. The auditor for the checkers audit should be a qualified and experienced quality controller and should be able to check a garment thoroughly as per the buyer's specification. The auditor should himself randomly pick up the garments from each checker's past pieces. These pieces should not be given to him by the supervisor or any other personnel. He should do the audit and any checker at least 4 times a day in order to get a representative checking efficiency of the checker. Pre-shipment quality audit. Quality audit is an examination of small number of garments from finished stock. A quality audit is recommended to be followed after packing of goods begins, and audit should be conducted daily to ensure that the shipment is of consistent quality. These are taken as representative of the finished quality going to customers as first. The main objective of the pre-shipment quality audit are to check the other parts of the system, obtain figures which can be compared with figures of in-process sampling and final inspection, giving comparisons of the effectiveness of the above two systems. Look at garment from the customer's point of view and analyze result. Guideline. The auditor for the quality audit should ideally be from the senior management and should try and scrutinize the product from the buyer's point of view. The auditor should himself randomly pick up the garments to inspect from the day's production. These pieces should not be given to him by the supervisor or any other personnel. Quality audit is an everyday process and should be undertaken without fail. The following points must be checked for conformity with standard. Carton size, oversized carton are not allowed. Carton quality. This includes the carton gross weight as well as net weight. Carton tape. Carton should not have factory or the vendor's name and address printed on them. The following points must also be checked for conformity with standard. Carton's marking should be clearly marked. Unsorted or broken pre-packed carton numbers packing list must show all the details. Packed quality. Packing size ratio in a carton. All garments to be packed along with the individual polybags. Finally, check that loose pieces are not packed. The type of fold according to packing instructions. For correct barcoded ticket with correct placement. Use of scanners to read the barcodes. Size clips that are present if required. Hang tag positions. Adhesive size strip placement. Garments for workmanship, fit and measurement quality as per the washing audit.
In the apparel manufacturing industry, there is no shortage of standards to measure quality. Manufacturing processes, equipment, teamwork, and accountability are all important, but if the quality of fabric falls short, nothing else can make up for it. Apparel manufacturers judge fabric quality in a number of ways, including color, drape, hand, durability, conformance, and number of defects. Detecting flaws is critical for quality. In-process inspection helps ensure that factory seconds don't pass as firsts. If the inventory of seconds exceeds just 3% of output, profitability can be seriously affected. Identifying problems early also lets fabric makers make improvements in subsequent production runs. Bars, mispicks, streaks, slubs, and knots may sound like peculiar terms, but for a cloth inspector, these are the names of fabric defects they've been trained to detect.
You have come to the end of this unit. To summarize, in this unit, you have learned about in-process sampling, 100% sampling, and quality audit. You have also learned about quality assurance for raw materials, spreading and cutting, sewing, finishing, and packing. You have also been given an overview of inspection standards and guidelines for various stages of manufacturing process. You have now reached the end of this course. Thank you.